I'm trying to show that it's reasonable to believe in the Torah. And I gave two arguments so far. Now, when you try to show something's reasonable, there are really two jobs. One is to show there's evidence of favor, and then the other is to say that if there are criticisms, you can answer them. Someone raised yesterday the question about the age of the universe, scientific matters. So what I'd like to do today is talk about two famous scientific matters and show you that we have what to say. And then tomorrow and Wednesday, I'll take you through, as best I can, one more piece of positive evidence. But I think, especially in today's climate, if you think that we're under pressure from science, people feel very defensive. Science has a gigantic prestige, most of which it doesn't deserve. And they feel if they're going to take a position which puts them at odds with science, they're just not going to be able to handle it. People are going to regard them as having fallen off the deep end. So let's first talk about the age of the universe. That's what the question was asked yesterday. There's only a little bit of a discrepancy. The current scientific picture is 13.8 billion years, and we are in the year 5,775. So there's just a little bit of a difference there that could be addressed. And given much time as we have, I'll talk also about the theory of evolution. 13.8 billion years. How do they get such a figure? How do they manage calculating something like that? Well, there is the computed distance of the galaxies and the speed of light. If they're that far away and the speed of light tells you how fast light is going, then you know how long it's been traveling, so you know how old the universe is. And you have radioactive decay. You have stuff that's radioactive and decays, like uranium. And we have a half-life law which says that over a certain period of time, half of it will decay. So you assume that once upon a time it was all pure radioactive. And then you say, well, there's only 2% left. So in the first period of decay, half-life was down to 50. And the next one was down to 25. The next one is down to 12.5. And if the half-life is 100 million years or something like that, so you add up the hundreds of millions of years and you get a much longer period of time. And then as far as the Earth's age is concerned, you have ice core samples that go down and record the layers of ice over thousands or tens of thousands or hundreds of thousands or millions of years. Cores of rock, which is supposed to go back billions of years. You have a variety of different ways in which you can calculate the age of the universe, and the happy fact is that they coincide more or less. About 10 years ago, there was a little problem that there were some stars that were older than the universe. That doesn't fit too well. And then they revised some figures and some measurements, and they somehow brought it into line. I mean, there are some tensions of the picture, but that's how it's done. Now, there is an assumption underlying this picture, an assumption that is taken for granted and accepted so widely that people don't bother to mention it. But it is an assumption nevertheless, and that is that the laws of nature that we are using to calculate this result have stayed the same always. They've always been the same laws. So the speed of light has always been the same speed of light. And the force of gravity has always been the same force of gravity. And the half-lives of the radioactive elements have always been the same half-lives. And so it goes, that there are the laws of nature which we use to calculate backwards. Well, if it's only 2% radioactive, and it started 100% radioactive, and it's a half-life, so you need so and so many half-lives to get down from 100 to 2, assuming the half-life has always been the same, then you can add them up and get hundreds of millions or billions of years, if it's always been the same. If the speed of light has always been the same. If the force of gravity has always been the same. If so, then you can add them up. One ought to ask, what reason do we have to think that it's always been the same? Is that supported by observation, by evidence, by calculation? Calculation on the basis of what? Usually, when you make calculations, you're using the laws of nature. Now we're asking about whether the laws of nature were constant or not. Not obvious how you're going to go about that kind of calculation. Now let me tell you a story. Maimonides was confronting Aristotle. Aristotle wasn't in favor of 13.8 billion years. Aristotle said the universe is infinitely old. It's a big gap between 13.8 billion and infinity, right? The gap is infinitely big. And he had all of science and all of philosophy on his side. The best thinkers understood the universe has no beginning. And here we are with, in those days, instead of 5,000, with 4,000. How are you going to face an opponent who says that it's infinitely old when you say it's 4,700 years old? Here's what Maimonides did. He said, imagine the following scenario. Child is born, a male, and a few months after birth, his father takes the child to a community of only men, no women. Child grows up and becomes an adult, and he begins to wonder. He never sees any new members. So he asks his father, where did we come from? How did we begin? We people. We, and he does, males, of course, that's all he's ever seen. And his father tells him, well, there are others who are very much like us, but different in some respects. And every one of us starts out as a miniature inside the abdomen of one of those. And after 9 months, comes out and grows to be the way you see us. So the young man says to his father, let's see, when we are miniatures inside the abdomens of those others, can we breathe? And father says, no. Can we eat? Father says, no. Can we drink? Father says, no. So then he says, well, then what you're telling me can't be true. This can't be true. Everyone knows you don't breathe for 4 minutes, you're dead. You don't eat for 3 months, you're dead. You don't drink for 3 weeks, you're dead. Your story can't be right. Now, given what he knows about the world, his objection is correct. He, observing what we would call life after birth, humans living, or even animals living, you cannot survive without breathing, you cannot survive without eating, you cannot survive without drinking. It's just not possible. You just die. Of course, the truth is that the fetus in the womb exists in a very different condition, a condition he can't even imagine. And under those conditions, you don't have to breathe, you don't have to eat, you don't have to drink. Things are very different for the fetus in the womb. After birth, there's a radical change in the way that creature survives, supports itself. Since he can't imagine, because he has no experience, nobody told him about it, nobody explained it to him, he can't imagine what it's like to be that other condition of a fetus. He can't accept it as correct. Maimonides says that the 6 days of creation that we read about in the Torah are the gestation of the world. It's the world in its embryo state. It's the world before birth. The 6 days of creation are the development of the world before birth. The end of the 6 days, the birth takes place, and what we see is only after birth. We're like that boy who becomes a man in a community of men who knows only the lives of people after birth, because that's all he's ever seen. We too know only the lives of the universe with the laws that we see operating, because we were created into that world, and that's all we've ever experienced. But before we were created, before we were brought into the world, the laws that we see weren't operating. Indeed, the 6 days of creation are not only the creation of stars and galaxies and space and time and energy, it's a creation of the laws of nature also. It's a developing and building and creating of the laws of nature. And what we know only after the creation process is over, what we experience of the world, so to speak, after birth. And that makes it very difficult for us to imagine what the world was like when it was developing, when the laws didn't apply. Just like that child who grows up in the community of men has no conception of what it's like to be a fetus in the womb. And therefore, projecting our reality backwards without limit, saying that the laws have always been the same, is just as inappropriate as that boy saying to his father, the story you're telling me has to be false because no one can live without breathing. Because, in fact, the laws that we see weren't operating during those 6 days. By the way, people always ask, how did the plants grow on day 3 with no sun in the sky for photosynthesis? It's a non-starter. You're worried about photosynthesis because that's part of the world that you see. That's just like the boy asking, how could we live if we weren't breathing? Well, you don't happen to know, but we had an umbilical cord. That's how. So we didn't need to breathe. During the 6 days, plants didn't exist from photosynthesis. That's not how they existed. They existed in a different way because the law that requires photosynthesis wasn't in place yet. So Maimonides says, if you assume, like Aristotle did, more or less, that where's a chicken come from? An egg. Where's an egg come from? A chicken. Chicken, egg, chicken, egg, chicken, egg, forever. Where are you going to get an egg without a chicken? Where are you going to get chicken without an egg? Chicken, egg, forever. And the skies, I told you last time, for the Greeks, the skies never change. The skies never change. The heavens never change. So, especially circular orbits, things go around in circles, nothing ever changes. It's been that way, and it's always been that way. Well, that's just assuming that what you see today has always been that way. Now, you can make your assumptions. It's a free world. But like I said the other day, you don't have to roll over and play dead because of somebody else's assumptions. That's the assumption that he makes. We have a different picture. Our picture is that it only started after the end of the 6 days. That being the case, it's incompetent to project backwards into that 6-day period because of a different state of the world was operating at that time. And by the way, if you need to back this up from a source that's not a religious source, Niels Bohr, one of the great founders of quantum mechanics, said that projecting back to the early age of the universe is not competent for this reason from a scientific point of view, because the laws have been changing, the laws have been evolving, and that being the case, we don't know what the laws were in earlier ages. Projecting back into those ages is just not competent. So it comes out that the scientific world has its picture, and its picture is based on an assumption, and as I said, it's a free world. You can make whatever assumption you want. But if we decide that we're not going to accept that assumption because we have a different point of view, we are perfectly justified in saying that we don't have to accept their conclusion, and we can accept our conclusion. Questions up to here? Okay. Now, that's just the age of the universe. If you ask, well, what about all the fossils? What about all the developments? What about all the sequence of events that the scientists describe? There are several ways to handle that, but I'll give you one which psychologically is easier, psychologically is more comfortable. I don't think in logic it's any better than the others, but I'll give you something which you can lean on with some confidence. And this is due to Rabbi Schwab, who wrote this in an article, published it, and it was accepted as one way to explain the Jewish point of view. Not the only way, and as I say, in logic it's not necessarily the best way, not any worse than any others. There are others that are equally good, but I'm just telling you this way because it's easier to relate to. Because the laws that we see weren't operated during the 6 days, things happen faster. Everything the scientists describe is true. There were dinosaurs. It's just that when they talk about 100 million years where the dinosaurs ruled the earth, so in our time frame that comes out to be about an hour and a half because things happen much faster. And if you'll say, as one critic did, but then if it's happening much faster, it violates the laws of nature. Things will have to move too fast for them to be stable, bones will break and so forth and so on. Yes, that's true. It'll violate the laws of nature, but we said now 3 times already that during those six days, what we call the laws of nature were not operating. After all, the Torah describes it in wholly miraculous terms. God made this, and God made that, and God commanded, and the earth brought out this, the earth brought out that. It's all described in miraculous terms. So from our point of view, it's not surprising that we think it's a miracle. That's the language of the verses. And that being the case, we say it all happened. It's just that you stretch it out. You stretch it out because you assume that the speed of light was always the same, and the force of gravity was always the same, and radioactive decay had always had the same half-life. You assume that, and you use your assumption. Okay. But we reject the assumption, and thereby we're not stuck with the 13.8 billion years. Yeah.
Surely this idea is in, it's a possibility, but you always talk about probabilities. Right? It doesn't sound to me like a probability, it sounds more like a possibility.
Well, that might be correct, but then on the same grounds, the scientific picture is also only a possibility. It's not a probability, because how shall I describe that the laws of nature have always been the same? Is that a probability? Do we have any evidence?
It's more probable than it was different and then it changed. I think it's more probable to say, what we see at the moment has always been. I think that's more probable than there was a random change for some reason.
I'm not sure why, since you don't know what happened.
No, we're talking about possibilities. I'm just saying this possibility is more probable.
But I understand that, but the claim that something's probable needs evidence in its favor. What evidence are you going to offer in favor of assuming that it was the same, rather than acknowledging that it might have...
There's no reason to think that it's suddenly... There's no cause for a sudden change, so I can't think of a reason for a sudden change, so I'd say there wasn't a reason, and therefore it's always been the same.
Okay, that sounds to me not really like probability. That sounds to me more like I can't think of a reason. Now, I can't think of a reason is really a confession of maybe the limits of our imagination, or the limits of our inventiveness, or we don't want to tolerate novelties. Probability has to be based on something more than I can't think of a reason. That doesn't make a probability. It's really a question of method. If you're going to tolerate the possibility of changes, then the sky's the limit. So then you'd be left with no method at all. If you're just going to arbitrarily allow someone to say that changes took place, then you could have any number of changes, and you lose any way of making progress in understanding anything. That's the way the objection, I think, is put. And I think it's a reasonable objection until you look at the details. Let me give you an example. A person is accused of a crime, murder. Now, we have his footprints outside the residence, and we have his fingerprints at the place of the murder, and we have a motive, and we have a murder weapon that's the same kind that fired the bullet and found in his possession. Looks pretty bad. Looks pretty damning. The defense attorney says, my client is being framed by the mafia. Yes, the footprints are there, and the fingerprints are there, and the gun. And my client is being framed by the mafia. Will that get him off? For sure not. Because if you could get off with that, you could never convict anybody. No matter how much evidence you have, you could always say it's framed by the mafia. Right? So that's not going to be tolerated. But now let's suppose, change the case a little bit. You have the footprints, you have the fingerprints, you have the murder weapon, but you also have an eyewitness who saw the defendant 100 miles away at the time of the crime. Now you have a contradiction in the evidence. And now the defense attorney says, you know where the circumstantial evidence came from? The footprint, the fingerprints, and the gun? He's been framed by the mafia. Now I think there'll be an investigation, because there's a contradiction in the evidence. You can't stop every criminal prosecution on the grounds that it was a frame-up, because then you can't convict anybody. But when you have a contradiction, you have all the circumstantial evidence, and you have an eyewitness who says no, then investigation. Maybe he was framed. Framing does happen. It does happen from time to time when there's a contradiction. So that's what I say here. Yes, if someone can simply say, you say 13.8 billion, I say 5 billion, because things change. And he says 24 billion because things change the other way. And somebody else says 5 minutes because he thinks change the other way. That makes it free play, and it means you can't make any progress at all. But I claim that we have a contradiction in the evidence. Because on the one hand, you have what the scientists present to us on the basis of their assumption that the laws have never changed. On the other hand, you have our evidence for the Jewish tradition, period, like the evidence for Revelation, like the evidence of prediction of the future history of the Jewish people, which we saw yesterday, came true against all expectation. So if I look at my picture of the world, my whole picture of the world and its evidence, I see evidence in favor of the scientific picture based on the assumption that things have stayed the same. And I see evidence in favor of the Jewish picture, which doesn't agree with the scientific picture. And I have to make sense out of the whole thing. Making sense out of the whole thing, I say, well, I have a way to explain away the scientific evidence. Scientific evidence is based on an assumption, and the Jewish picture has a different assumption. There, I'm not just short-circuiting all inquiry, short-circuiting all investigation on the grounds that I can always say it was different. I'm appealing to real evidence on the other side. And I don't think that is illegitimate. Someone who makes it up and just picks an arbitrary time and says, I can say it changed at that time, I agree. That will short-circuit all investigation. It's not appropriate, but I'm not doing that. So I think we have a reason to say that. Yeah.
So regarding your claim that the scientific laws of physics have changed, specifically the Niels Bohr quote that you mentioned, claims like dinosaurs have existed for 65 million years prior to the advent of humans. The scale that they use specifically is Earth years, 365 days, 24 hours. Moreover, when he claimed that these laws of physics have been malleable, I think he was referring to specifically the events surrounding the Big Bang. So my question is, how do we reconcile these types of issues ultimately with your claim?
Well, maybe I didn't explain it clearly enough. I wasn't saying that Bohr will agree with us. All I was saying was, if someone has this picture that the laws are always the same, I want you to know that there is a respectable scientific point of view that they haven't always been the same. I'm not saying he's going to agree with our 5,750.
No, that's not what I was saying, but I think what he was saying was after the events surrounding the Big Bang is that these laws have remained pretty stagnant, and I think it would be very hard to find a scientific community that disagrees with things like the theory of gravity or relativity past this point. So now we understand that dinosaurs did exist 65 million years prior to the coming of humans. This isn't the same scale that is utilized in the model that you proposed, so I'm wondering, how do we reconcile this?
Okay, again, I'm not proposing Bohr as a model for us. I'm just pointing out that it's not uniform that the laws have stayed the same forever. Let me give you an example of this kind of thinking within the scientific community that is accepted, although it's coming under pressure now. There are problems with the Big Bang, problems that were known since it was officially adopted in 1965, problems that were known. One is the horizon problem. The universe, when you look out and look at the distribution of free energy, it's very, very uniform. Something like the 1 part in 10,000. How come it's so uniform? Now, you know very well, if you take a warm glass of water and you put in some ice, after a while, the ice will melt, and the glass of water will be cooled off, and it'll all be a uniform temperature. We know that when things are different temperatures, you put them together, there's a heat flow, and they become of roughly the same temperature. But that takes time. It takes time. You drop the ice in for 2 seconds and pull it out, it's not going to happen. So now the thought was, well, in the early universe, there were all sorts of different pockets of different temperatures, but it evened out. So they did some calculations, and they found out that it was expanding so fast there wasn't enough time for it to even out. So how come it's so even? How did that happen? Are you going to tell me that it started out exquisitely even? That doesn't sound natural. That doesn't sound like what we expect in a universe without a designer, without a creator. We expect it to be random, and that means patchy. Along came Alan Guth in 1980 and invented cosmic inflation. Cosmic inflation says this. You imagine the Big Bang, and what you imagine is a world that starts expanding quite rapidly, and then the expansion slows down because of gravity. And you think of that as a more or less uniform process. It's expanding and then slows down and expands more slowly. That's not what happened. That's not what happened. What happened is this. The very, very first fractions of a second, it was expanding fairly slowly. Then it shot up by a factor of 10 to the 80 in a trillionth of a second or less. Gigantic jump. And then it slowed down again. And it slowed down to the leisurely expansion that we observed, except for the acceleration, which was discovered a few years ago. Okay, that's called cosmic inflation. It was a moment of inflation. Now here's the picture. Slow expansion, bang, inflation, and then continuing slow expansion. Now they calculated. Look at the first phase. The first phase of slow expansion. Was there enough time when it was that small and expanding so slowly? Was there enough time for the ice to melt and make the water the same temperature? Was there enough time for heat flow to go from one place to the other? The answer, yes. Oh, Baruch Hashem. No, I wouldn't say that. I would say, we found a solution. We now can understand why the universe is so even in temperature, because the earliest phase was one that was slow enough to balance out the differences in temperature. But what happened to the uniformity? What happened to the uniformity? It's expanding the same way. Gravity's slowing it down. How did you stick in a blip? A change, right? A change. A gigantic change. Expansion of 10 to the 80 power in a fraction of a second. How do you stick it in? Well, we stuck it in because we need it. And if we put it in, then we can make things work. It's okay. So how committed are we really to things have always been the same? Not very. It's a starting position. It's a position which you take because, perhaps no reason to go otherwise. But when you have a reason, you can cancel it in a second. You can cancel it in a second because you need it. So it's not as if we have a hard scientific commitment to things haven't always been the same, a uniformity. It's a starting position, which is maybe simplicity, or maybe where else are you going to start? Because if you try to start other ways, it's arbitrary, but it isn't that solid. I'll tell you something else without going into great detail, unless you like. I know the details on this. When it was discovered the universe is getting bigger, or let's put it this way, let's be more careful. When it's discovered that things are moving away from one another, galaxies are moving away from one another, it was thought that means the universe is getting bigger. That means in the past it was smaller and smaller, further and further in the past, smaller and smaller. Well, there's got to be a limit to this. You can't be smaller than zero. So there's got to be a beginning. Nobody liked that. Stephen Hawking says the idea of a beginning smacks of a creator, and we didn't want that. So they invented a theory which could avoid that. Called the steady state theory. You can look it up on Wikipedia, which avoided that. Now, maybe this isn't necessary, but for those who will get it, the steady state theory says that space is infinitely big. No beginning. The universe never began. It's been always doing the same thing. Things are moving away. That's true. They're moving away from one another. But it's been going on forever. How come we're not all infinitely spread out? The answer is new stuff is coming into existence throughout the universe all the time. New stuff out of nothing, out of nowhere. New stuff is coming into existence all the time. Of course, you don't observe it because the rate is something like in a cubic meter of space in 100 years, you'll get an electron. No, you're not going to see that because you're not going to be able to discover it. With that, the density stays roughly the same. Now, let's just stop and take stock of this. The scientific community adopted new stuff coming in out of nothing. What happened to the conservation laws? That mass energy always stays constant. Well, if we need to balance things and we need to have more mass energy coming in, so we'll just take more mass energy coming in. Because in the laboratories, you don't see that. The laboratories aren't that sensitive. We don't have a laboratory around for 100 years monitoring a single cubic meter of space to find an electron. We never did that. So how solid are these assumptions that things are really the same and really constant and so on and so on? When you get into trouble and you need it, you can cancel them at will. So they aren't really that well established. They're a starting point that you take for convenience sake, for simplicity's sake, but they're no more than that. If there were real probability, you couldn't do that. If there were real probability, you couldn't do that. You'd have to have counter evidence against the probability. But since it's only an assumed starting point, if you need to cancel it, you can cancel it. And nobody stopped to think, new stuff coming out of nowhere? Out of nothing? How could that be? Forget about how it could be. We need it. We need it to make a consistent picture, so we put it in. In 1965, when they discovered the background radiation, they took it out because they didn't need it anymore.
Sure, because it's a theory, that's why they have it. They have a theory, and it's not proven, and then until it gets proven, and then find them, that's when it only properly gets put in. You have theories, and then you put it in.
No question, but the point is this. No one said, but that's so improbable. You can't use it. You can't use it. You got to look for something else. It's not an acceptable theory. Nobody said that. They said, okay, you want to change that, and then things will work out. Okay, that's fine. If you had real probability, if you had real evidence in favor, and somebody would say, oh, I got these experiments, these observations, so forth and so on. If I just assume that water boils at 120 degrees centigrade, everything will be fine. What will people say? Excuse me, it doesn't boil at 120 degrees centigrade. It boils at 100 degrees centigrade. You can't do that because we know it's not right. We have too much evidence in favor of this. So look for a better theory because that theory is not going to work. Right? Nobody said that, which means that you don't have a theory with real positive evidence in its favor. You have an assumption, a natural assumption, and it's a natural assumption you keep up until you need to change it, and then you change it. That's not the same as having real positive evidence. That's why I said I don't like the word probability there. Probability means you've done some experiments, you've checked alternatives, you've checked predictions. None of that has been done. Okay, that's the age of the universe. Now, I want to tell you one thing about evolution, and I'm issuing this as a challenge, not only to you, but to your teachers, your professors, your philosophers who believe in this. I've been issuing this challenge for 30 years, and some pretty famous people issued it recently. Only I have my way of presenting it, which I think is very intuitive. And if you can get me an answer to this question, I'll be better educated, and I'll give up one of my key arguments. I'll give you an analogy, and then I'll tell you how it applies. I have an object, and on this object I have painted, on one of its sides, I've painted an X. Now, I tell you the following story. I threw the object into the air, and it landed on the X 3 times in a row by accident. By accident. I didn't throw it in any special way. It's not weighted. It's not magnetized. It hasn't got ridges that catch the airflow. I threw it up, and it came down 3 times in a row on the X by accident. Do you believe me? Can you believe me? 3 times in a row. Okay, most people are satisfied 3 times in a row. Pretty acceptable. But I left out one key piece of information. What didn't I tell you?
How many sides?
How many sides the object has. Maybe you were assuming it was a coin. If it's a coin, the probability of getting the X 3 times in a row is 1 in 8. That's 12.5%. That happens more than 1/10 of the time. Not hard to believe that I threw a coin in the air 3 times and landed head 3 times in a row by accident. That sort of thing happens 1/10 of the time. Suppose it's a shilyagon. Shilyagon has 1,000 sides. So that means the probability of getting the X 3 times in a row is 1 in a billion. I think you shouldn't believe it if I tell you it's a shilyagon. But I suppose I refuse to tell you what object it is. I won't tell you. But I tell you my story. I put the X on one side, I threw it in the air 3 times in a row, 3 times in a row, it landed on the X. Do you believe me or not? I think the appropriate response is, you haven't given me enough information to make up my mind. You're telling me something happened by accident. Well, to believe that, I've got to believe the probability is reasonably high. If you told me it was a shilyagon, I reject it right away. 1 in a billion, that doesn't happen. Told me it's a coin, I'd accept it because it's 12.5%. You don't tell me how many sides it has, so you don't tell me what the probability is, then I can't make up my mind. Now, I think that's rock solid. Find me somebody who disagrees with that, and thinks you can have an answer without knowing the probability, I'll be very surprised, but I'll learn something new. That's rock solid. Okay, evolution tells me that the development of life on the planet, from the first self-replicator to butterflies and orangutans and redwood trees and porpoises and the rest, all of it is due to an accidental process in this sense, that the variations that created new forms are accidental. Sure, selection determines which ones will survive because of the differential reproduction, fine and good, but the generation of new forms is by accident. cosmic ray hits the DNA or whatever. Okay, so give me a probability. Tell me, according to your picture, what's the probability of getting this envelope of life from the first self-replicator by the process that you describe? They can't do it. They haven't. They've been challenged to do this for 40 years. The latest challenge came from Thomas Nagel, card-carrying atheist, one of the most eminent contemporary philosophers, published a book with Oxford University Press called Mind and Cosmos, and he said, where's the probability? If you can't show me the probability is reasonably high, let's say 1 in 10,000. That's reasonably high. What? Probability of what? That your process will do it in the 3.8 billion years since the first life is detected on the planet. If you don't do that, so then why should I believe it? If you don't give me a probability, there's no reason for me to believe it. It remains a possibility. Is evolution possible? Sure, leprechauns are possible also. We talked about that. But without a probability, you haven't given me enough information to make up my mind. So to present it and say that I have to roll over and agree is simply wrong. It's wrong on straightforward intellectual grounds. And with all of the outraged response to Nagel's book, no one was able to refute that point. But maybe I'm missing something. Write to your professors, write to professors of biology and professors of philosophy, and get me an answer to this question. How am I supposed to be required logically to accept the theory of evolution if you can't give me a probability? Yeah.
Well, that's something I struggle with, but I feel like the unlikely probability of humans developing through the process of evolution is also a reason to believe in God as well.
Well, you see, I'll show you why my problem really cuts both ways. When you try to say that certain things that happen through evolution is very unlikely, you have to presuppose you know exactly all of the factors that will contribute to the evolution. But we don't know that. I don't know if you've heard of Stephen Kaufman at the Santa Fe Institute, California. He says maybe there are laws of self-organization in nature. Chemically, we know there are. Ilya Prigogine in the 1980s won the Nobel Prize for self-organizing chemical systems. There are certain chemicals, you put them together and heat them, and it changes from red to blue every half second, exactly. Red, blue, red, blue, red, blue, red, blue. Nobody planned that. Nobody predicted it. They were mixing the chemicals, and that's what happened. If you heat water on the stove, you have a pot, you have a central heat, that forms convection currents. The water goes up in the middle, down on the sides, and that determines how it boils. And when boiling starts, that has interrupted. You ever notice when you're boiling in a pot, in a kettle, that just before it boils, it gets quiet? And then it starts to boil? That's because the convection currents are changing at that time. That means the water doesn't move around randomly. No, it moves in strict formed patterns, and it always does that. So he said, if there are self-organizing principles in chemistry, maybe there are self-organizing principles in biology also. Now, of course, the key word in that sentence is maybe. Yeah, but maybe, for all we know. In which case, evolution could have happened much faster. Things just organized, daisies organized into a frog. Maybe so. Can I prove not? Have we tried all the possibilities? No. So that means I can't say that it's too unlikely because I don't know what the principles are that are moving the changes. Richard Dawkins, by the way, you know what his chair was at Oxford University? It was a chair in the public understanding of science. He never was a scientist. He never made any scientific discoveries. Selfish gene he took from a fellow named Williams, who published it a decade before. His chair is in the public understanding of science, which then means you can be more forgiving when he makes gross errors in science. The blind watchmaker, he said, sure, if you're looking for the development of life by a purely random process, just putting all the pieces together, but that's not how it happened. It happened by starting changes, and then with changes, taking off the best ones. And when you do that, it's easy. He said, I took a random list of 50 letters, and I transformed them into a quote from Shakespeare over lunch. I set my computer to making random changes, and picking out, let's say, 10 random changes on the string, picking out the one that's closer to the target quotation for Shakespeare, and over a few thousand changes, I got Shakespeare out of nonsense. Okay. As someone had written in a book before that, called by Denton, I forget his first name, it's called Evolution Theory in Crisis, pointed out, you can't just make changes and pick the best. When you make the changes, the thing it changes into has to live. It has to survive. It has to reproduce. What you really should have done, if you wanted to make a model, you should have started with one sentence of 50 letters, and your target should be another sentence of 50 letters, make random changes and make sure that each one in between is a full-formed, perfect English sentence. Try that. The answer is, if you try that, you'll never get there. Because English sentences in the sets of letters are almost vanishingly small. You'll never go from sentence to sentence by random changes. But Dawkins didn't do that. So what did he do? He chose a false model. And the false model is that you have too many degrees of freedom. We don't know how many degrees of freedom there are. We don't know what the principles are. So you say human evolution is too unlikely. It's only too unlikely if you say the only things that are going on are ABC. And ABC can't produce it. But there might be DEF going on also. Nobody knows. So to convict evolution of a mistake on the grounds that it's too unlikely falls before the same ignorance that I'm accusing them of. We just don't have enough information as to how the probability works. Yeah.
I'm confused. Why do we need to know this probability? Say you have this item, you look at it and go, wow, so many sides, fine. You see this one X from there. And the guy flips it over once, now the next, flips it over again, now the next, flips it over the first time, now the next. You don't need to know how many probabilities there were. We don't go, wow, that happened on X 3 times.
Yes, it happened 3 times, but did it happen 3 times by accident? No one will believe that. They'll say, it's fixed, you've got a magnet in there, and the table's magnetized, or it's weighted on that side, or you can throw it in a particular way. No one's going to believe it. They're going to say you're a good magician and you've hidden the mechanism.
No, so assuming it's not that case, and the point is that...
Assuming it's not like it's meaning what?
No, as in assuming that it hasn't been weighted, and he throws it over 3 times, it doesn't matter the probability. My point is simply, it doesn't matter the probability if it happens.
On the contrary, the probability matters a lot for me to decide whether it happened by accident or not. Houdini was tied up and he had handcuffs on. They put him in a sealed case. Sealed case had metal bands around it. They threw it down into the water, and 15 minutes later he came out.
So, but I'm saying is that if you can see evidence, if you can see evolution, right, it doesn't matter about the probability because you can see evolution.
No, you don't see. Well, now the word evolution, as Ernst Mayr pointed out, has at least 5 different meanings. What you see is event after event after event. The evolution I'm talking about is supposed to explain why those events took place. What's the mechanism that caused them to take place? You don't see that. You don't see the random mutation and the selection going on. What you see is this species and this species and this species and this species. We're talking about what you don't see. And I'm not questioning the fossil record, which could be questioned, but I'm not doing that. I'm not questioning. Let's say that you have this order of development of life. But why did it develop that way? The critics are saying your picture of why it developed isn't adequate. One reason it isn't adequate is because you can't give me a probability of it's happening that way. That's what Nagel argued in this book, among a lot of other things. So I think that as far as the age of the universe and evolution is concerned, we are in a position where we can neutralize the critique. I don't say we can show that we're right and they're wrong. I say we can neutralize the critique. We don't have to run scared from the scientific critique. And that means that we can hold up our heads in public and say, look, you have your position. I'm not attacking your position, but I don't think you can attack my position either. And therefore, we have to just practice respectful coexistence. Okay, that's the two issues. Tomorrow and Thursday and Wednesday, we'll talk about Jewish survival. Jewish survival is also a source of evidence for the truth of the Torah.